Okay, so we're going to go through the product rule, and remember that we probably need to apply the chain rule as well in some of these. So I'm going to do that. We're going to go through, and some of these are going to have... Some of these are going to have the chain rule. All right, so what we're going to do is, using our formula sheet, which you need to remember this, those people who don't know any Year 11 methods, memorise the product rule, which is really easy, and you also have to have the quotient rule memorised as well. Oh my god, what is going on? Okay, so I think I need more RAM on this computer. It just absolutely craps itself. Okay, U is equal to sine of x. V is equal to tan of x. U dash is equal to cos of x. And V dash is equal to sec squared of x, straight off your formula sheet. Now, one thing you'll notice is if you set it out like this, it's this times this plus this times this. So if I do that, therefore we can say that dy dx, because we've got to use as long as your answer's in the notation that it says, if you go f dash of x is equal to, we've got a function y. You're going to have to let y equal some function of x if you're going to do that. So stick to the same notation, ladies and gentlemen. Otherwise you'll lose a mark in an exam setting. So dy dx is equal to tan of x times cos of x, which is cos of x times sine of x over cos of x, which is sine of x over cos of x, plus we're doing sine of x times plus sine of x times cos squared of x, if you over cos squared of x. And that is equal to, if I was just to cancel those out, we're going to take sine of x as a common factor, and I'm going to say that that's 1 plus cos squared of x, 1 over cos squared of x is sec squared of x, isn't it? Now, 1 plus sec squared of x is what, Jordan?
Tan squared.
It's tan squared of x. Do we have to simplify that? No, we don't. No. Okay, this time, what are we doing? We're letting u is equal to x, v is equal to log e to the x. U dash is equal to 1, v dash is equal to 1 on x, and therefore I'm doing the same thing. I'm just adding the product of both of those. Okay, so therefore f dash of x is equal to x times 1 on x is 1 plus log e to the x. Yes? Awesome. This time we've got the product rule with the function on the right, v if you like, v is actually using the chain rule. So you need a little bit more time. First of all, we're going to say let b, I'm just going to make something up. Let b is equal to inverse tan of e to the x. And I can let z equal to e to the x. And I'm just going to make up that dz dx is equal to e to the x. And we can say that b is equal to inverse tan of what? Z. Why am I not using u and v again? Because I might use it over there. So if you're going to do this sort of stuff, you don't have to do it this way, but you might want to find the derivative of inverse tan of e to the x on the side first. Okay, that's my advice to you. All right, but don't go using u's and v's in different contexts, because then you can lose method marks because you're technically not correct. db dz, if you like, db dz is equal to, what's inverse? 1 over 1 plus z squared, isn't it? So therefore, I've got db dx is equal to this times this, which is e to the x over 1 plus z squared. Isn't z e to the x? So isn't it e to the 2x? There you go. I've just worked out the derivative of the thing on the right. So what I can do now is I can say that u is equal to e to the x. V is equal to inverse tan e to the x. U dash is equal to e to the x, because that's the derivative of that. And v dash, well, we've done it over here. Okay? Now, this is a bit of an abstract way of doing it, but I've said b is equal to inverse tan, and I've used the chain rule, and I haven't used u and v. So I could do that if I wanted to. If you have your own abstract way of doing it, you could do it. That's the same thing. Okay, so v dash is this thing over here, which is e to the x 1 plus e to the 2x. So therefore, what we're going to say is we're going to do u v dash plus v u dash, and we're going to say that dy dx, please keep the notation that the question has, dy dx is equal to e to the x tan, inverse tan of e to the x. And e to the x times e to the x is e to the 2x, isn't it? Is that correct? E to the x times e to the x is e to the 2x, and that is plus e to the 2x over 1 plus e to the 2x. Do you think your calculator's going to have it in this way? It does? Let's do it. The derivative of e to the x inverse tan e to the x. Let's have a look. Okay, we want to find the derivative of, with respect to x, of e. Now, you need this one here. E to the power of x times, what is it? Is it inverse tan?
Yeah.
Times inverse tan of e to the x. So it's got e to the x inverse tan e to the x plus e to the 2x on e to the 2x plus 1. Is that the form we had? Okay. Good. All right. Now that's a tricky one. If you can do that, it's probably pretty fair to say you understand product rule, because you are applying product and chain rule in the same one. Did you girls get that right? Yeah. Fantastic. All right. Now this time, going to do the same thing. U is equal to x, v is equal to inverse sine of x. Given the last one, we probably shouldn't even have to do this one, but I'll do it really quickly. U dash is equal to 1, v dash is equal to 1 on the square root of 1 minus x squared, and therefore we can say, leave it in the same notation, f dash of x is equal to inverse sine of x plus x over the square root of 1 minus x squared. Are we okay with that? Okay, I'm going to stop the video here, and that is product rule. 8 minutes, that's much better.